All right, so today we're going to talk about the x-intercepts of a quadratic relation. Now, the basic quadratic relation we're actually looking at looks like, so it looks like ax minus r, x minus s, and that's why we were studying the factoring in the last lesson, because parabolas and quadratics can be changed into this form. Now, we already studied about the quadratics relations for the vertex form. Remember, if we found the vertex form, if we had something in the vertex form, the vertex was HK. If we were looking at something that was in the standard form, this tells us that we have the Y-intercept is equal to Y equals C in that case, right? Now, in this section, we're actually going to be studying a thing called the intercept form, sometimes known as the factored form, which is given by this. Now, the reason why it's called the intercept form is this factored form that we have here. We can use my favorite thing. We can use opposite world on these brackets here to find our x-intercepts. And in this case, our x-intercepts are x equals r, because r is the opposite of negative r, and the second one is x is equal to s. So by putting stuff into this form, we end up getting the x-intercepts for our graph. So let's go and take a look at this problem here. The three sets of equations that are represented, so this one, and this one, all represent the exact same graph, right? Now, the first one is the first version of this problem actually gives us some information. The second gives us some information, and the third gives us some information. Now, this equation here is called the vertex form. So when we go and find the vertex, remember, it's opposite of what's in the bracket. We're using opposite world, right? So we end up with 2 and negative 16 for our vertex. Now, our y-intercept is always this last number here. So our y-intercept is negative 12. And for our x-intercepts, what did I say? We're using opposite worlds, right? Opposite world means that we can have one or more intercepts. And in this case, we have our intercepts are equal to x equals negative 2 for x plus 2, and then x equals positive 6 for our other x-intercept. So now let's go and do the second here. The second set of equations is this, right? The first equation tells us that our vertex is negative 1, positive 8, and our y-intercept is, you guessed it, the last number here, okay? And we're going to get y is equal to negative 6 for the standard equation of the line, and then finally for the factored form or intercept form of the line, we're going to call this, we're going to know that our x-intercepts are using opposite world, right? Which means we've got x equals negative 3 and x is equal to 1. Now remember, with anything that is dealing with a y-intercept and an x-intercept, right? Anything that goes along here is what we call the y-intercept, right? So the point that crosses is called the y-intercept. So if I had a point sitting on there, that'd be my y-intercept. And then anything that goes along here are called x-intercepts. And that's what we're talking about today. So now let's just go on the rest of the lesson here. When given the intercept form, we know the a value. Okay, so the a value shows the steps for the step method. Remember, we start with, for y equals x squared, the steps are 1, 3, and 5. And then when we change to our new one, we multiply by whatever a is to get 1a 3A, 5A, right? And the x-intercepts of 0. So if you look at this basic equation, it always has an A, and you'll notice for the vertex form, there's an A, the standard form, there's an A, and for the last one, the intercept form, there is an A. They are all the same value of A. Now, those things give you the idea of whether the graph opens up or down, and then these tell us where they cross the x-axis. So here is the thing. Remember, if I have this, x minus r, x is equal to r are my x-intercepts. Our x equals r and x is equal to s. So now if I'm looking at this graph here, this equation here, it tells us that A is 0.5 and our zeros are opposite world. So for x minus 3, we're going to write x is equal to 3, otherwise known as the x-intercepts. When you hear the term zeros, they're always referring to the x-intercepts. So you say x is equal to 3 and x is equal to negative 11. Remember, we must use opposite world for anything inside a bracket. So now let's go on to these problems here. Example number 2 says factor the quadratic relation and use the factors to find the zeros. Okay, let's do that. Use the zeros to find the zeros. Then we're going to sketch the graph using the zeros and the y-intercept. So for the y-intercept on this first graph equation, all we have to do is look at the last term on here to find that our y-intercept is y is equal to negative 42. Now, let's go and find the x-intercepts based on our graph. So just give me a moment. So for the x-intercepts, we start with our basic equation. Y is equal to x squared plus x minus 42, right? So we're looking at this last thing, and when we're factoring, we have to find all the possibilities of negative 42. So for 42, we can multiply 1 times 42, 2 times 21, and 3 times 14, and 6 times 7. Now, I'm going to show you a hint here. So inside here, we have to have a negative number, right? But you notice this number here is a positive. So that means our negative number is going to be on the smaller of the two numbers of each. So each one of these numbers that we have here are less than the numbers that they're paired with. So now let's add them together. This one doesn't, negative 1 and 42 doesn't work. Negative 2 and 21 doesn't work when you add to get the middle number, which is assumed to be a 1. And we end up with negative 6 plus 7 being 1x. Perfect. So we can write our final factorization to be x bracket, and our answer is going to be negative 6 and positive 7. So that means my x-intercept are x equals 6 because of opposite world, and x is equal to negative 7. Okay. All right. So now here are the points that we have. So if you look at this, right, to find this value, our y-intercept, our point is 0, 42. That's our first point. Now for the second point, i.e. the x-intercepts, we're going to have 6, 0, and negative 7, 0 for our points. Now, we're going to use our graph to help us plot our points on the graph. Now, if you take a look at the points, I'm going to make these points very big so we can see them. So the first point is 0, negative 42. So 0, negative 42 is right here. Okay? And then we have 6, 0 for our second point. So our point on the left is 6, 0, and our other point is negative 7, 0. Now, here is a big trick. To find the axis of symmetry, you need to know that the axis of symmetry actually comes from the midpoint of where our X-intercepts are. So all we have to do is add these two together and divide by 2. So for this calculation, we found that the axis of symmetry is the vertical line, the mirror line, right? Which is 6 plus negative 7 divided by 2. So it's exactly halfway between those 2 points of 6 and negative 7. And you find that it's at approximately here, right here. Okay, now if I have the mirror line, this allows me to find the alternate point that we're missing. So the alternate point for y is equal to negative 42, which we should have had up there, is going to be down here, negative 42, and it's just going to be right here. So now, if I want to graph this, I can literally just connect the dots nicely and make a nice curve, get our vertex hitting our axis of symmetry, and bring that puppy back up to the other side, right? But you notice that my vertex had to be slightly beneath where our y-intercept was, because it has to kind of go down and then move back up through the y-intercept to get to the rightmost root, otherwise known as the x-intercept. So now let's go and do this next problem that we have right here. So we're going to do the same thing again. We're going to identify the y-intercept. So to identify the y-intercept, we're going to do this. We're going to look at it and say, okay, we're looking at the y-intercept. So therefore, our y-intercept is y is equal to negative 48. Now, as for my x-intercepts, right, we have to basically copy down our equation, and then we're going to have to factor it. So we got y is equal to negative 3x squared plus 24x minus 48. So now let's zoom in on that, because this graph is very special. This equation is very special because what we're going to have to do is we're literally going to have to factor out a 3. We're going to have to pull out a 3 from our previous calculation. Okay, so we're going to pull out a 3 from this equation. And to do that, you're going to get minus 3, and then we have a bracket that represents what's left over. So negative 3 divided by negative 3 is just x squared. Now, 24 divided by negative 3, I'm going to tell you right away that because I have a positive divided by a negative, I'm going to have a negative. So now I just have to figure out what 24 divided by 3 is. And you find out it's 8x. And then we have to do the same for 48. Now, 48 divided by 3 is 16. So, but we have a negative divided by a negative, which becomes positive. So now we end up with positive 16. So now we need two numbers that multiply to 16 and add to negative 8. So let's do that real quick. All right, so we have these three possibilities, right? And now we need to figure out whether we're going to have a negative or a positive, or two negatives or two positives. So in this case, when I'm looking at positive 16, I can either have two negatives or two positives to make a positive answer, right? Now, the big hint is the fact that I have -8 at the end, right? -8 tells us that we need to have two negative numbers in order for this to work. And with a little bit of luck, you'll find out that 4 and 4 work, but more importantly, -4 and -4 work for the addition to 8, right? -4 plus -4 is 8, so we're going to use that. And we substitute. So now we end up with -3, x minus 4, and x minus 4. So the intercepts are, the x-intercepts are, well, isn't that x equals 4? It's just the opposite, right? And guess what? It's also x equals 4. So that's a strange thing for our graph. Let's see what that means. But first, we have to go and identify all the points that we've got for our graph. Remember, we had y was equal to 48, right? And for our graph, we also had x is equal to 4. So for our y-intercept, we've got 0, 48, -48. And for our x-intercept, we've got 4, 0. So those 2 points are all we have got for our equation. So let's go and take that information and put it onto our graph and see if we can make some sense of this. All right, so we have 0, 4. So I'm just going to plot that on my graph. 4, 0. So we're going to plot that on my graph. And then we also have 48, 0. So that's 0, -48, which is down here. Okay, so if I have a point that doesn't cross, there's not 2 points, I'm going to give you a big hint. If your graph does this, just touches the x-axis, then you have something that looks like this. You have something that looks like this for your equation, right? So we've seen that before when we were looking at our parabolas that shifted left and right from the base graph. So our new graph looks like this. And because our vertex is plotted nicely, we can go and kind of set up our axis of symmetry. And all we have to do is we have to find a point that's exactly 4 over from here on this side, okay? So I'm just going to readjust my screen a little bit, and I'm going to find that point. So 4 over to the left at 48. So here's 48, right? And then I just got to count 4 spots over. 1, 2, 3, 4. So that's where my point is. And we'll just paste it in there. And then we'll just copy the rest of our graph. And there we go. We have our nice graph, nicely constructed. Okay, let's move on to the last 3 questions of our practice today. So now we're given this equation. Y is equal to 3x plus 4 squared minus 48. And we know that this is vertex form, don't we? Now, this question has asked us to express this relation in standard and in intercept form. We need to know the vertex, the y-intercept, and the zeros. So let's go through all of the math for this. Let's first identify the vertex. So the vertex has to use opposite world for the x. So instead of plus 4, we get minus 4. And we get our y from the end, which is 108. So now we need to find the y-intercept. So to find the y-intercept, what do we got to do? So in this case, we have to focus on changing our information from vertex form to standard form. So let's just focus on that and then move on to the next thing and state our y-intercept in zeros. All right, so for our our vertex form to standard form, the first thing we do is we write down our equation. Then we basically write 3, but then we have to double this. So now we've got x plus 4, x plus 4, minus 108. Now we need to expand this. So let's do that. So we got y is equal to 3 bracket x squared plus 4x plus 4x plus 16. And how did I get that? I basically just did this, and then I did this with those two. So that's what we've got. And then don't forget the minus 108. Now, we're still not quite finished yet. So we still got to go and fix this bracket. So we got x squared. We have to bring these two things together and add them to get plus 8x plus 16. And then we have minus 108. So now, once we've done that, the next stage, we have to take the 3 and hit it with everything in the bracket. And by doing so, we drop our bracket. So we end up with y is equal to 3. 3 times x squared is 3x squared. And then 3 times 8x is going to be 24x. And then 3 times 16 is going to be 48. And then minus 108. So now all we have to do to find our y-intercept and find our standard form is this. Y is equal to 3x squared plus 24x. And we have to add the stuff that we've done, that we've underlined in green. And that gives us negative 60. So therefore, our y-intercept is y is equal to negative 60. So I'm actually highlighting that, right? And then what else we should do? We should go back up here and make sure we highlight what our vertex is. Because you know what? A lot of times you can't see it. And maybe when I'm reading your tests, I won't be able to see it. So now that we've got our relation to find our y-intercept, right? We also have the equation in standard form. So why don't we highlight that as well? So this is your standard form. So we have the vertex, the y-intercept, and now we must calculate the zeros. To calculate the zeros, we have to actually think of this. For the zeros, we must do this. Zeros means factor the, what is that called again? Not sure. Factor the standard form. So in order to find the zeros, we must factor the standard form. So let's do that. So we'll start with y is equal to 3x squared plus 24x minus 60. And here's what we're going to do. Because we have the 3 sitting in front of this entire equation, we need to pull that 3 out from the equation. So let's do that. So pulling out our 3 means x squared is left by itself. But now we have to take 24 and divide it by 3. So we end up with plus 8x. And now we have to do the same for negative 60. So it's going to be negative 20 because we take 3. 60 divided by 3 is 20, and we're good. So now we must factor all the stuff here that's underlined in green. And here are the factors of negative 20. And these are our factors. Now, I'm going to look at this, and I got to start using my head here. If I have a positive, right, and it's a negative timesing to 20. That means one of the numbers must be negative. Now, because we have a positive, we have two numbers that add up to positive 8. That means my smaller number is going to be negative for each one of these. All right, so now we can add. So check. -1 plus 20 gives us 19. Doesn't work. But -2 times 10, does that work? That works as 20, but when we add it, yes, it works. So that is our answer. So we can write this as x, and then we're going to have -2 and plus 10. So that's it for our answer. So this means that our x-intercepts are, remember, we're using opposite world for this. X equals, instead of -2, it's +2. And instead of -10, it is, +10, it's -10. And there we go. So we have answered all of these problems. And the best part is all the answers are there and they're all boxed around. And you, as a student, have answered all of the questions by doing those 3 steps. Set up the vertex, find the y-intercept by changing our information into standard form, right? And then use it to find our y-intercept. Then once we find our y-intercept, we use the standard form and compute the factored form. That's it. I know that was really in-depth, but it had to be done. So now let's go and do example 3. So this question says a football is clicked from ground level. Its path is given by -4.9 t squared plus 22.54 t, where h is the ball height and t is the ground, okay? And t is the time in meters per second. How long is the ball in the air? So to find this, here is the big trick. Let's put a big trick here. Big honkin' trick. Always factor when we want to know when something hits the ground. All right, so let's do that right now. So we start by starting with h is equal to -4.9 t squared plus 22.54 t, right? So we're going to pull off -4.9 t, and we're going to find out what's left in our bracket. So we pull off -4.9, so you're left with t, not t squared, but t inside, and then you're going to have to divide this positive 22.54 t by this, right? In doing so, you're going to get the following. So 22.54 divided by 4.9 is 4.6. Now, here's the trick. We have a positive divided by a negative, which makes this a negative. So t is -4.6. So remember what I told you. When we want to find out how long something is in the air or when it hits the ground, you have to factor first, right? This factoring allows us to find the x-intercepts, right? So let's do that. In this case, we don't really have x-intercepts. We have, you know what, let's just call it x-intercepts. So the x-intercept is going to be, well, not really x, it's going to be t is equal to, well, the first one that we have here is not is this one, right? Big trick. Anytime you have t by itself, the answer is t is 0. But now this part, this we know as the other bit. So we say t is also 4.6, right? So let me tell you what this means. This is the starting time. And then this one here is the end time. So what does that tell us? Therefore, the ball was in the air. You take the end point minus the start point gives us 4.6 seconds as our final answer. Okay, now let's move on to the last problem for the day. So this one has Ferd, and he's on a bike, and and his path is modeled by the relation here, right? Now, the fact that it's modeled by this relation, where h is Herd's height above the ground and d is the horizontal distance from the ledge, both are measured in meters, we need to find the height of the ledge. And when Ferd lands on the ground, how far is he from the ledge? Let's go. So when we start this problem, we have our equation, right? So we're going to take our equation, and I'm going to give you something interesting about this equation, right? The key idea is they say, what was the height of the ledge, right? I'm going to tell you the height of the ledge. So the height of the ledge is at the start. So we need to use the height, the Y-intercept. So that means that the height is equal to 8.4, our Y-intercept. Now, it's 8.4 meters, right? Now, that is question number 1. So when we're looking for something at the start, the key is to recognize that you're looking for something at the start. When they say, what was the height of the ledge? We're asking how high was it at the beginning, right? So we're going to say it's 8.4 meters high. Now, here we go. The next part, let's go and write this in black too. The next part was how far was he from the ledge, right? So if you were looking for how far from the ledge, far from the ledge is x distance, right? So that means we need the factor of it. So we need the factorization. Okay, so let me show you how that's done. And that's done by the X-Intercepts. And we start by doing our factorization. Shun. Now, let's just make sure that we can focus on just the factorization. So you got to understand we're trying to find the X-intercepts, right? So we got negative 1.2 d squared plus 7.2 d plus 8.4 is the original equation, right? And then what we're going to do is we're going to pull off the negative 1.2, which is on the d. So you're left with this. Now, from here, you need to remember that we need to find a number that multiplies to 7, right? So it multiplies to 7, and there's only one multiplication, right? Now, we have to kind of figure out what's happening here, right? So multiplies to not 7, but let's go negative 7, right? Now, the big hint is that one of them has to be negative. And the big hint, the thing that tells us that it's on the bigger number of these two here, which is going to be our final answer, it's going to be the negative sign is going to be on the -7, because if we add -7 plus 1, you're going to get -6. So now we have h is equal to 1.2 d minus 7 d plus 1, which now tells us that the x-intercepts are the following. D is equal to 7, and D is equal to -1. Wait a second. -1? That doesn't make sense. Let's see why it doesn't make sense, all right? Is it possible to go back in time or go back in distance? Yes, but we only start on a cliff. Can you go back into a cliff? I don't know. But I'm going to say no, it doesn't work, and let me explain why. So let's zoom out and talk about this in depth, right? All right, so you remember that originally our y-intercept was 8.4. So that's 0, 8.4, right? And for our x-intercepts, we had D is 7 and D is -1, right? Now ask yourself, if Bird is standing on a cliff, can he go into this cliff, this solid cliff, to go and stand at the bottom of the cliff? I don't think so. That's why D is -1 is impossible. The one thing that they didn't tell you was that you assume that the distance always starts at least 0. Okay? It only starts at 0 but never goes behind 0. Okay, for our D value. And that's it. So the distance he traveled is literally going to be from the edge of the cliff to where he hits the ground. That's it. And we're done.